Ever wondered how the electrician fixes the wiring in your house? Or how the mechanic troubleshoots the electrical system in your car? It all starts with understanding the basics of Ohm's law and circuit analysis. So buckle up. This journey into the world of electronics is about to get even more exciting. First up, a quick recap of Ohm's law. This fundamental law states that the current flowing through a conductor is directly proportional to the voltage across it and inversely proportional to the resistance. In other words, the formula I equals V divided by R is your key to unlocking the relationships between voltage, current, and resistance in a circuit. Next, let's talk about series and parallel circuits. In a series circuit, components are connected end to end, forming a single path for current. Here, the same current flows through all components, and the total resistance is simply the sum of individual resistances. On the other hand, in a parallel circuit, components are connected across common points, offering multiple paths for current. In this case, the voltage across each component remains the same, and the total resistance is calculated differently. This brings us to the voltage divider rule. In a series circuit, voltage divides among the resistors in proportion to their resistances. The higher the resistance, the more voltage it drops. Now let's add another layer of complexity with Kirchhoff's laws. Kirchhoff's current law, or KCL, states that the total current entering a junction equals the total current leaving it, ensuring the conservation of charge. Kirchhoff's voltage law, or KVL on the other hand, states that the total voltage around any closed loop in a circuit equals zero, reflecting the conservation of energy. To analyze complex circuits, use Ohm's law, KCL, and KVL in a step-by-step manner. Begin by identifying series and parallel components and then simplify the circuit gradually. Apply Ohm's law to calculate currents and voltages. A multimeter is a handy tool for measuring voltage, current, and resistance in a circuit. Remember to set the meter to the correct range before taking measurements and to connect the probes correctly, red to positive and black to negative. Now let's see how you can practically apply these concepts. Try building a circuit with a power source, a resistor, and a load, such as an LED. Experiment with different resistor values to regulate the voltage across the load. For homework, practice analyzing series and parallel circuits using Ohm's law and Kirchhoff's laws. Also, explore more about multimeters and how to use them effectively. And that's a wrap for today's lesson. You've now got more tools in your electronics toolkit. As you practice, you'll gain confidence in your ability to work with various circuit configurations. In the upcoming lesson, we'll delve into components like capacitors and inductors, which add new dimensions to electronic circuits. Until then, keep experimenting and keep learning.